Dear students,
Today,
dear students, today my first class, practically my virtual first class, a new experience for me. And my topic of discussion is mathematics. And today being 10/9/20, mathematics of class 11. My name Ashish Kumar Chopra. My affiliation is AKC. And for any feedback, my email number is achopra@gmail.com. Now, as far as mathematics is concerned, for science students in particular, or students in general, you must say, is a very important topic. You cannot say that my sixth subject is mathematics, or mathematics is not my area of interest. It has to be, and if you have taken up science, mathematics is your core subject. And you have to be really good in this particular topic. And I would say, you not only enjoy mathematics of class 11 and 12, you need to relish it, you need to enjoy it, you need to enjoy working problems. Because all problems here would be now no more a type of memory, it would be practice-oriented problems, and you will go on practicing it so and so that you master the art. Now, as far as mathematics is concerned, our mathematics is divided into two portions. One is the project, and the other is the theory portion. In case of theory, it is 80 marks. A subjective and objective paper will be there from the council, and 20 marks is the project. Project is what you do in theory. We put it there as a project. So therefore, in our mathematics of class 11, it is divided into two parts, theory as well as project. This project marks 20 are internally assessed. It is the procedure followed by our school, and in this particular 20 marks, generally students score good marks. Now, first and foremostly, before I start a topic or different topics or different subjects of different areas of mathematics, I congratulate all of you for performing well in your class 10 examination, and I also welcome you to our SDN school. I hope you have a lot of dreams, and I pray to God that all your dreams are fulfilled by these 2 years, and in future course you will pursue different careers. Now, this being a virtual class, I don't know who you are, how many students are there, nothing is known to me yet, but still I will come to know. And it is expected very early you would have direct contact with all the students in your future. Now, in case of mathematics, the topic of mathematics is divided into these 7 areas. First is the sets and the functions, then it is the trigonometry, algebra, coordinate geometry, calculus, mathematical reasoning, and statistics and probability. This is the 7 branches under which our syllabus will proceed. And all these topics would be there as an application in class 12. Whether trigonometry, whether algebra, whether coordinate geometry, these are all applied. We would use them in our class 12 syllabus. Now, as far as this sets and function is concerned, students from background of ICSE and CBSE have basic concept of these sets and functions. Here in our school, while we proceed with the syllabus, we will start with sets and directly reach out to calculus. Because the unit element of calculus is sets and functions. We will further elaborate it. We will proceed further by starting with set and functions. So this and these two would be covered together. As far as the trigonometry is concerned, trigonometry algebra, we may start these two together, or we may start any two of these three together. Because we have started a session a bit late, we need to cover fast. And from all of you, a lot of cooperation is needed. Being a very core topic of yours, you have to take it very seriously. And my fundamental concept is very simple. You should have a separate exercise copy where all your discussions will be there. Keep it aside. Do not use a diary or a rough book or loose sheets. Do not do that. Each day, each topic as we proceed should be at one place, so that you can refer to it in later classes. Here, our trigonometry and algebra has different branches, different topics are there. As we proceed, I will let you know. Trigonometry, again, many of you have done in class 10. We would elaborate that and you would enjoy it. As far as coordinate geometry is there, it is, I have written analytical geometry. It is no more solid geometry. So, how many theorems are there? Students generally ask me when we start with class 11, so geometry again. But I would suggest, or I would say, no, it is not solid geometry now, so that you only memorize. It is analytical geometry of 2 dimension and 3 dimension. Analytical means you analyze, and when you analyze, and then you proceed. And it's a very important field of mathematics, has a lot of scope in geometry. Mathematical reasoning, or you may call it logic also. Mathematical reasoning, again, it is a computer type of language where you have done many things as binary, your truth tables, your fallacy tables, and so on. So this is mathematical reasoning, and it is in the syllabus is very concise as far as mathematical reasoning is concerned. In case of statistics and probability, the syllabus is again very mechanical, very formula-based, nothing to memorize. In general, you need not memorize anything, not to memorize anything. You need to understand, you need to practice well, and you need to enjoy doing mathematics. The core concept is simple as that. Nothing else. So therefore, in case of statistics and probability, this is also very mechanical, formula-based, and probability is very interesting. and you will enjoy it. Today, what I have decided is I will start with algebra. And in case of algebra, we have two topics. One is indices, or you may call exponents, and the second is logarithm. So starting with algebra, I start with two topics, and those two topics, indices and logarithm, are not part of our syllabus as far as higher secondary syllabus is concerned. But they have lot of application. They have lot of application. Each topic, starting from calculus and in class 12, it is of lot of importance. Whether it is integration, whether it is differential calculus, whether it is application of calculus. So these two topics we would need. I will give you the basics just now. And the books you will follow is the very common book is SND, Higher Secondary Mathematics. Higher Secondary Mathematics. By SM Professor Dr. SM Day. This is the basic book we will follow. You will procure it. Any edition would do. If you get a hold of an old edition, no problem with that. A new one is well and good. My suggestion for the second book is Rudiments of Mathematics. Of Mathematics. By M&M, Professor M&M. Dr. M&M Mukherjee is my, I have studied under Manavendra Nath Mukherjee, Professor of Calcutta University. And the third book for my suggestion is, for reference you may say, is R.D. Sharma. A very good book, lot of problems, lot of examples, and it will give you the subjects. Interest is there in this particular book. These two are there. If you can get hold of R.D. Sharma, R.D. Sharma would prepare you for other competitive exams also. In addition to these two, in addition to any one of them, get hold of R.D. Sharma also. And old edition would do also. You need not worry. It is not necessary to get hold of an old edition, a new edition. An old edition is sufficient. So therefore, starting with my topic, and my topic of discussion is indices and logarithm. In case of indices, and these laws of indices or exponent laws are known by you. In case of laws of indices, you have to know that the laws are A to the power n plus n, maintaining A not equal to 0. Second law is an by an minus n. Third law Third law is a to the power m, 2 to the power m, a to the power m. And number 4, a, b, whole to the power n, a n, b n. Number 5, a to the power 0, a not equal to 0. Sixth law, a 1 by n is the root of a. And seventhly, a minus n is 1 by n. A to the power n, this is an exponent quantity. 2 to the power 5, 3 to the power 5, 2 to the power 6. Similarly, a to the power n, here a is said to be the base. A is said to be the base. And these are exponents in powers n, n. Now when I say a to the power n into a to the power n, we sum up the powers. Mn could be any integer, Mn could be any rational, say for example, whole number, natural number, fraction, and so on. So therefore, first law you may say, or first property of laws of differences is a to the power n. Similarly, reaching out to second, third, fourth, fifth, any number, however large it may be, 2 to the power 0, 1, 3 to the power 0, 1, minus 3 to the power 0, 1, 5 to the power 0, any number to its power 0 is always 1, 1 and 1. Maintaining a condition that a not equal to 0. You may say, sir, 0 to the power 0. 0 to the power 0 is undefined. 0 to the power 0 or 0 by 0 is undefined. 0 to the power 0 or infinity to the power 0. Infinity by infinity. 0 by 0 are still yet to be defined. I come to the very important number 6, which states that a to the power 1. We generally get confused what this really means. A to the power 1 by n means nth root of a. Nth root of a. Suppose I say a to the power half. It means square root of a. You need not get confused. Because at times I have found out the students are confused as far as this 1 by n is concerned. Suppose you write root a, it will be written as a to the power half. Or cube root of a, it will be written as a to the power 1 by 3. So therefore, this is very important area of concern. The last one is a to the power minus n. A to the power minus n means 1 by a to the power n. Do not make mistake. N may be any quantity, or fraction, or integer, or whole number. So therefore, a prime number, even number, whatever it is, if it is a to the power minus 2, it means 1 by a squared. So therefore, these things should be very clear. Now, I will ask you to solve this. Solve. 2 to the power x is equal to 16. So this is known to me. 2 to the power x is equal to 16. And 16, sir, I know it is 2 to the power 4. 2 to the power x is 2 to the power 4. X is equal to 4. Sir, my solution is x is equal to 4. I will proceed further. I may say solve my second question. And my second question is 3 to the power x is equal to 27. 3 to the power x is equal to 27. Now you will say again, sir, 27 I know it is 3 to the power 3. 3 to the power x is 3 to the power 3. X is equal to 3. Sir, done. Solution right. And my solution is x is equal to 3. I am able to solve exponential equations. These are exponential equations. Yes, I am able to solve. Fine. I move on to my third example. And my third example is solve 10 to the power x is equal to say 110. That question, let's understand the question first. This solve bases are same 2 to the power x, 2 to the power 4. Answer solve. Solution is x to the power 4. Fine. 3 to the power x, 3 to the power 3. Yes, x is equal to 3. Fine. But when my equation is 10 to the power x is equal to 110. So if my question is solve 10 to the power x is equal to 110. Yes, an exponential equation. Yes, sir. Solution has to be there. But I am not able to solve this particular equation, the exponential equation, by the concept of our indices. I cannot solve it. But solution of this exponential equation is there, is existing. You cannot say, sir, it is unsolvable. No, certainly not. But by the tools of indices, by the laws of indices, I am not able to solve. How to solve this? How to find solution of this particular exponential equation is our challenge. And for meeting this challenge, to accept this challenge, we have our new topic, that is logarithm. That is why I told you, indices as well as logarithm are two topics. As far as our syllabus is concerned, they are not part of our syllabus. You will find in your textbook, in this assembly, essentially it is not part of syllabus. But it has to be part of your thought process or your concept of mathematics. Without knowing logarithm, I feel you cannot proceed. So here is the case where there is a necessity of knowing logarithm. How to solve this exponential equation? Certainly an exponential equation, solution of x is there, value of x is there, which satisfies this equation. But I am not able to solve by our own laws of indices. To solve this, to find solution of x, I have to use logarithm. I have to use topic log. Now, to know log, first and foremostly, I need to know laws of logarithm. And I am about to apply those laws. But before that, let me start with an exponential equation. And then how do I transform that particular exponential equation to a logarithm equation? Things should be very clear. You have studied linear equation, you have studied quadratic equation, you have studied cubic equation, you are studying here the exponential equation, and there is logarithm equation also. What is that? We are about to discuss. Now let us say suppose we have an exponential law. This is an exponential equation. A to the power x is equal to n. This is an exponential equation, fine. This particular equation, the unknown is x. Unknown here is x. I have to solve for x. And when this is an exponential equation, I may write this particular exponential equation as think once again, think again. This is an exponential equation. This is a logarithm equation. Both are same. This is written in indices form, and this is written in logarithmic form. Very important point. You are introducing log, you are introducing an instrument of mathematics. That is log, a vital tool of mathematics, to an exponential equation for it to solve. This particular equation I am not able to solve. Certainly, solution exists. Or what is the solution? With the concept of indices, by the laws of indices, I am not able to solve. So how to solve it? I have to use my concept of log. That is logarithm equation. There are basic points one should know. Number one, you have to keep these things in mind. Whenever you write log, never use capital L. Always use small l. Now the point is, this topic is a bit elaborate. I need further time. I have to stop here, and I will continue my next class with the same equation, which is the logarithm equation. X is equal to log n base a. Thank you very much for today's class. Hope to meet you soon. With this topic of logarithm, I will continue. Thank you once again.